let's have some science fun. Are you ready for some more science fun? We've been talking about energy. What is energy? And did you hear it from Dr. Binox yesterday? He said the same thing. And that's what, I know some of you might think he's a little creepy. Some of the kids last year thought he's creepy. I think he's cute. And he helps me teach science. And he's really good. So, and I like that he says some of the same things. So Dr. Binox and our book, Miss Monroe, has told us that energy is what? The ability to do work. Very good. That's what energy is. It's the ability to do work. There are 3 kinds of energy that we talked about. What were those 3 kinds? Light. That's why you can see me. Because there's light energy. But we also said light energy has another energy. Yes, heat, right? Because a light bulb gets hot. So light energy, heat energy, and what else? What was the other kind of energy that we... Oh, yes, sound energy. Did you catch my hint there? So we have light energy, heat energy, and sound energy. Those are our 3 kinds of energy. Now, we also have sources of energy. What were the different sources, the natural sources, not like, oh, a light bulb, an electric socket. No. What are the sources, the natural sources in our world that produce energy? Yes, sun, solar energy. Remember we talked about that? What else? We get energy from the water, right? We have water wheels many times that are using and helping with that energy. Wind, yes, windmills. There's a lot of those that help with energy. Remember we talked about those beautiful white ones that they, put out so that helps to power many different things around certain towns or whatever. And then we have fuel energy as well, which could be gas or coal or oil. Those are our sources of energy: fuel, wind, water, and sun. Okay, so don't forget those. And then our fuel, water, wind, and sun energy can be turned into electrical energy. And that's what we're going to talk about today. Electrical energy. We use electrical energy all the time in our home. We use electricity to turn on our lights, to have our air conditioning, to play our video games, to charge our phones. We use electricity all the time. How does it work? Well, we're going to look at page 23 and we're going to figure out some interesting things about our electrical energy. First of all, let's look at the terms to remember. The first term is conductor. Now, it doesn't mean the conductor in a train or the conductor of an orchestra, even though those guys are pretty cool too. This conductor just simply means something, a material through which electricity can flow, okay? So a conductor is some kind of material that lets electricity flow through it. Electricity can't flow through just anything, okay? But if it's a conductor, electricity can flow through it. And that's important to know because if you need electricity to go through something, you've got to have a conductor. Then we have an insulator. An insulator is material that electricity cannot flow through. So it's not able to go through certain materials, but electricity is able to go through other materials. And then we have a circuit. A circuit is the path on which that electricity flows. So it has to take a path in order for the electricity to work properly. And we'll find out about that as we go through this next couple of pages. So electrical energy, fuel, water, wind, and solar energy can be turned into, what did we just say a minute ago? Electrical energy at a power station. How does this electricity get into our house so that we can turn our lights on? How does that even work? Electricity flows from the power station and into our homes through special wires called cables. So there are cables that bring electricity to homes and businesses and schools and everything. There are those cables. An electrical cable is simply made of copper wires that are bundled and covered in plastic. So it's copper wires, and around those copper wires is plastic. because copper is a very good conductor of electricity. So copper does conduct electricity, but plastic does not. So that means electricity can easily flow through copper. Well, I love this little, I don't know, it's like a little kit that I got. And in the kit, it is doing some things with electrical energy in a sense. You can make motors and different things with this kit, but one of the things they have are these wires. And these wires are plastic, but I love the fact that it shows what is inside the plastic on the end. Can you see that? That is copper wire. So all of these little pieces right here are copper wires. This is what many of our cables that we're plugging in, they have copper wires in them, but it's protected with the plastic so that we don't get shocked every time we plug something into an electrical outlet. But those are the copper wires that are inside cable. These are good conductors of electricity. These would be insulators. They don't let electricity flow through them. Why are these wires covered in plastic? Electricity can be dangerous. We just talked about this. The electricity flowing through a wire is very powerful, and touching it could be deadly. Not just, ow, ow, I get a spark, I'm gonna try it anyway. No, it could be deadly. That means these wires need to be covered in something to block the electricity from flowing out to you and harming you very seriously. Plastic is a good insulator. An insulator is anything that electricity cannot flow through. So electricity cannot flow through plastic. It is a very good conductor in copper, but not through plastic. So that's why plastic covers those copper wires. A plastic wall switch protects you from electricity as you turn your light on. That's why you've always got covers over, those places where electricity comes from, so that electricity does not come out and harm you. Electricity can be flowing, working, or stored, waiting. Remember, we talked about those two yesterday. Batteries store electrical energy that can be used to power flashlights, toys, and electronic devices. How does a battery give electrical energy? Electricity needs a path to travel on called a circuit. Remember, we said it's got to have a circuit. When the electricity is flowing, we call this its current. So it has a current where it flows through. Do you see how the electrical current flows from the positive plus side of the battery through the wire back to the battery's negative side? So it goes from the positive side into that bulb, then comes back out the negative side. That it has to be connected. If both of those parts aren't connected, then the light bulb's not going to work. It has to complete the circuit. If the electricity makes a complete circle or circuit from the battery and back to the battery, we say the circuit is complete. When you turn a toy on or a light on, that is because of a complete circuit. Now, if you turn it on and it doesn't come on, if it's even inside the light bulb itself, there are little currents and little pathways that have to be connected. If they're not connected, that's not a complete circuit and it will not work. So if it doesn't come on, then something came disconnected somewhere in order for it not to work. Which picture shows working electrical energy? Which picture shows waiting electrical energy? So you've got batteries and you've got the lamp. Which one is working electrical energy? Obviously the lamp, because it's on, it's working, right? And which one is waiting electrical energy? Our batteries, obviously. If it's not the other one, then that's what it's going to be. So our batteries are waiting and our lamp is working energy. So let's talk about this on Comprehension Check. True or false? Write the word true or false in each blank. Copper is a very good insulator. True or false? I'm going to wait because you're going to write it in there. I'm not just going to tell you. Miss Monroe doesn't just tell you because I want you to think so that you'll know it for tests and quizzes. So copper is a very good insulator, true or false? Actually, I think I'm just going to do the whole thing without telling you, and then we'll go back through them, but you better put the answers down while we're going through this. Number 2, an insulator is anything that electricity cannot flow through. An insulator is anything that electricity cannot flow through. Think of what I showed you and what we just talked about. Number 3, batteries can store waiting electrical energy. True or false? Batteries can store waiting electrical energy. 4, true or false? Lights turn on because the circuit is incomplete. Lights turn on because the circuit is incomplete. True or false? 5, electricity in a copper wire is flowing working energy. Electricity in a copper wire is flowing working energy. True or false? All right, so what did you put for number 1? Did you put false? Okay, but if it is false, then what would be true? Because we have to discuss why the false answers are incorrect. So we look at what's underlined, the word insulator. So how could we change that word to make it a true statement? Copper is a very good conductor. Excellent. So it should be false because it should be conductor. What about 2? That is true because an insulator is something that electricity cannot flow through. That's why copper is not a good insulator. It's a good conductor. Batteries can store waiting electrical energy. Well, we already know that because we just figured that out on the page there. So that is true. Lights turn on because the circuit is incomplete? That doesn't make sense. And remember, it has to be a complete circuit or else it's not going to work. So that would be false, and the correct answer would be complete. Then number 5, electricity in a copper wire is flowing working energy. That is also true. Very good. Why is using a copper wire helpful in moving electricity through a circuit? Because copper is a good conductor. Very good. So you can just put copper is a good conductor. Electricity can flow through it easily, whatever you want to put, but copper is a good conductor. Why does the copper wire need to be covered in something like plastic? Because plastic is a good insulator and electricity cannot flow out and hurt you. Okay, you can just put it's a good insulator, that's fine, but just understand that copper is protecting you so that the energy doesn't flow out to you. So copper is a good conductor, plastic is a good insulator. It does not allow electricity to get to you, whereas if you touched the copper, not touched it, but if it were, if the wires were frayed and they were out, you should never ever plug in something where the wires might be kind of sticking out at all, because then that means the electricity can go through those to you if the plastic is not covering them. So if this had like a plug on the end of it and I went to plug it in, it's very dangerous because you can see even just that little part of the wire. If you can see any of the wire, get rid of those plugs because they're not safe, because they're not covering over every part of that electrical current that could come out at you. Okay, now I have to show you this really quickly. That little kit that I was telling you about, it gave me something where it said, okay, take this wire, and this is kind of copper wire right here, and a coil, it's really a coil, and I coiled it around this nail, okay, it's just a nail, coiled it around, and now I have a battery, and I have it not connected right now because I was trying this before I got on here, and the wire was getting hot because this battery is allowing energy to flow through it through this coil onto that nail, okay? We're gonna see what this nail can do. So I'm gonna reconnect the end of this coil. I try to show you to the top of that battery, okay? Oh, sorry. Trying not to let the coil, it wants to poke through, but the rubber band. Okay, so now I have these two parts on there. I think they're on there sufficiently. And I have some paper clips, because if the energy flows through here like it should, this should become a magnet. So let me see, because it's kind of being a little difficult. Oh. Do you see that? It became magnetized, and it's picking up the paper clips because the energy flowed through. But remember, it has to stay a complete circuit, because, whoops, I just dropped them. But I can pick them back up easily, because all I have to do is pick them up on here. But all right, let me see if that one will stay on. Let's see what happens when I break the circuit. When I break that circuit, that falls off, because it's not a complete circuit. So if electricity is going to work, the circuit has to be complete. And that complete circuit allows energy to flow through. So there's energy flowing from the top of the battery and to the bottom of the top of the battery to the bottom of the battery, the plus and the negative. And when it's flowing through there, it's going through these coils. This coil is hot right now. I'm feeling it. It's very warm. But because that energy is flowing through, now my paper clips are going to be magnetized again. And now I have an electromagnet from simply a battery and copper coiling. How cool is that, right? So something so simple, but it shows how a complete circuit is very, very important. And when you come back to school, I'll have another thing. I'm going to unplug this because, like I said, it is so hot. This whole nail and coil is so hot because it was connected, and electrical currents were flowing from the battery through that coil and the nail to make it electric and make it magnetized, because by itself it doesn't work. I can't pick up these paper clips and hope to make them stick because there's no electric current going through it. Cool, right? But when you come back, there's another thing that I'll show you that shows a complete circuit. And if you complete the circuit, cool things will happen. But you'll have to come back to school to find out. All right, I hope that you enjoyed that. One more thing to show you afterwards. Well, it depends on which order you watch this in. So maybe this is the last one. Bye. If it's not the last one, catch me in the next video. Whatever, okay? So I will see you later. We're almost to Monday. Almost to Monday, and I'll see your faces. All right, see you later, guys.